So, as we all know, the internet is everywhere. There are 3 billion users of the internet on a daily basis, and it was invented as a military project, and it's never strayed far from those roots. But just so we have a common lexicon, I'm going to give you a crash course in how the internet works. So data centers, facility used to have computers, they look like this, just racks and racks and racks of computers. They can be very tall, very wide. Their main cost is power. This is the crux. This is a fiber optic cable. This is the main difference between a data center and your network at home. Instead of using copper, it uses glass and light to transmit millions of times more information. Here's what this looks like in a data center. This is some cables running in a junction, and surveillance looks a lot like this. Here's a transatlantic cable. These run under the ocean and connect everything in the world to the internet. IP addresses are the numerical address for a device on a network. They have this format. This vector image is from Wikipedia. It's not necessary that you know about the numbers or binary, just that there's a numerical address. IPv6 is a newer version, and it fixes the scarcity problem of IPv4. It's been very slow to be adopted because ISPs make profit on scarcity. So by keeping IPv6 in the off the regular internet, they've ensured that no other ISPs can start up because there are no more IP addresses in the Western Hemisphere. These people decide that. MAC addresses are assigned to the hardware in your radios, either Bluetooth, Wi-Fi. Everything that's network capable has a MAC address. Those MAC addresses are given out, the prefixes are assigned to each vendor by the IEEE. They look like this, and even though they look like relatively anonymized identifiers, because of this prefix and the fact that you can look at it and see what kind of hardware belongs to that MAC address, you can use it to help de-anonymize users on a network. Then there's the domain name system, which takes those things like google.com we're all familiar with, Yahoo, and translates them into numbers, which are the IP addresses, so that your computer can get the content from another numerical address on the internet. So here's some maps. This is fixed broadband penetration. As you notice, there's a bunch of countries in the Middle East and North Africa that don't report data. It's either because it's not available or the governments are hostile to that kind of data collection. A lot of those places also have state-run telecom companies, so they would certainly have that information. A lot of places in the region are very hostile to NGO work, especially anything that can be seen as like an economic colonizer, like the World Bank or the IMF. So this data is very hard to collect. There's a couple ways to look at it. Here are geotagged tweets. As you can see, the same places tend to get excluded. Like most of Africa, South America, Asia, particularly the former Soviet states in the middle. And that can be, and here is a map of geotagged Wikipedia articles. So you don't necessarily have to be there, but you can see that even things about places disenfranchise huge chunks of the world. Like Western Europe and the United States are almost totally covered. And yeah, North Africa and the Middle East have a lot of desert, but so does the American Southwest. And as you see as you cross the Mexican border, the density of geotags in the US disappears. So it has less to do with geology than it does have to do with socioeconomic status of the users. Here are average download speeds around the world, and it's hard, I know it's hard to read, but the green is around 25, and the red is 0 megabits per second. And the reason that's so disproportionate is because, as you can see, the transatlantic cables favor particularly the United States, but also Western Europe and places around the Mediterranean. And those are also countries that have strong economies, so the investment in these cable infrastructure being so expensive, it requires enough users on the other end to make it worthwhile. Here's a map of all the internet exchange points, which are the particular type of data centers that's used to exchange traffic between networks, say between Verizon and Sprint or Google and Facebook. And this will give you an idea of where there are large internet points that your average, not consumer, but a company could plug into. As you see, the same places get excluded over and over again. So all this architecture you've seen, because of the centralization, because of the fact that there's like root certificate authorities, because of the fact that all of this data moves up what looks like a tree where each cable line gets bundled with others until you get to a data center where you have like millions and millions of users. It lends itself very well to surveillance. Snowden was able to show us exactly the extent of that. New York is home to at least a couple NSA listening posts. This was reported by The Intercept and was broken by Snowden. So 33 Thomas Street down by the Federal Building. This is where they listen to other countries' satellites. And you can see, you can see the satellites on the roof. They're like, say like 10 or 15 feet across, which means that's the size they use to connect to space. So they're almost certainly used to monitor satellite connections. Here's a slide from the Snowden leaks that shows the number over 30 days in, I think, 2012, that they collected 6 billion records at this location. And so when they say records, they mean instances of communication or metadata between two people they want to target, or even just one. If we zoom in on this last slide, you can see actually the types of data that they're collecting. Sorry. So you have and how they're doing it. So there's a variety of methods. They're using things like stingrays to pick up 2G and 3G signals unencrypted over the air. They're tapping marine cables that are running out of these buildings. They, in less developed parts of the world, high-powered cordless phones are used instead of cell phones. That will extend network coverage maybe 10 or 20 kilometers, and so you can pick those up over the air. Those are generally unencrypted. They're sniffing other countries' satellite data. They're tapping in the old telephone network from the 90s and before, and then they have this term DNI for digital network intelligence, which is a generic word for the internet. So things like Twitter and Facebook would fall in that category. So this is Project Windstop. It's run by GCHQ. There's no clear evidence about where this location is. GCHQ is the UK's version of the NSA. As you can see here, it collected 14 billion records in the same 30-day time period. Part of the reason for this gap between the US one and the foreign one is the foreign intelligence courts and the fact that it's technically illegal for the NSA to spy on American citizens. All other foreign partners collected about 4 billion records in that same time. Here's where the records come from. Green is low, red is hot. So you can see Iran and Pakistan have the most, less from Afghanistan because we have troops on the ground, and then more with their normal enemies, I guess, Russia, China. This is a NSA satellite outpost in Ontario. You can find it on Google Maps. It doesn't exist on any government records that I can find, but there's pictures in the Snowden documents. This one's in Cyprus. controlled by GCHQ, and is used to monitor NATO traffic around the Mediterranean. This one's in Australia. We don't know the designation number from the NSA, but we do know it's there. Here's the other one in Manhattan. It's Copper Mountain at 60 Hudson Street. It's one of the main data centers. Who here uses DigitalOcean? Yeah, they're there. Yeah, one of the 3 data centers. And then, yeah, so that one's kind of infamous in the documents because there's no doorknob on the door where the NSA equipment is. The agent would bring their own. So here's a leak. This is a slide, and again from the Snowden leaks, showing the exact mechanisms for copying. And you see a bunch of like code words here, like Blarney, which is used as a generic word for like gathering network intelligence. And then Fairview is the project that's being run out of Titan Point at the old AT&T building at 33, whatever, in the first slide. Thomas, thank you. So yeah, so essentially what they do is they take these like fiber optic cables and make a copy of it, of all the data going through it, and then they send it to a data center in Utah. There. With a little bit of guesswork and some experience, we can guess that there's cooling towers, power buildings, data halls. By some estimations, this will be the largest data storage facility in the world. And the NSA has been working on techniques for storing huge amounts of data. Even though the internet transits like many, many petabytes every hour, most of that data is redundant. So, like a tweet that gets retweeted 100,000 times, they'll only store one copy of it and then attach everyone else's metadata to it. And so that way they're able to compress the amount of data they need to monitor the whole internet. In addition, they have a project called Turmoil, and another project called Turbine that are used to either, in the case of Turmoil, attack encryption systems like on host computers, and then in Turbine to break the decryption using brute force or other like more clever techniques. So while we think things might be safe, it's only a matter of time. And China and a company called D-Wave Systems have both claimed that they have quantum computers that work. And if that's true, the one-way functions that we need for encryption to work no longer hold true. So this is from 2013 and shows a picture of like internet censorship around the world. Things have not changed a whole lot since this was taken. So in particular, these places like to censor social media because it makes it very easy for people to coalesce around things they agree with and come against the government. What a particular thing not on here is Egypt. While it did censor the internet in 2012 and in 16, for a couple of years they were doing okay. And then in Egypt in 2008, right there in the Mediterranean near the canal, one of the transatlantic cables was cut and it knocked down internet to huge chunks of the world just by a single failure. So that's not a very stable system. And then in 2011, the street protest started on January 25th, what you might know as Tahrir Square. And later that day, Twitter, Facebook, and all the social media roadblocks. The country's DNS, like top-level DNS servers were shut down. BGP routes were manually withdrawn by every sysadmin in the country. And Google deployed, and then within, I think, 3 or 4 days, Google was deploying tweet-to-speech technology so Egyptians could call and tweet using a PTSN phone. And then on January 28th, Barack Obama gave a speech reaffirming the right of everyone in the world to have internet access and how what Egypt does now is like irreversible. And then you can see the mistakes they made then playing out and now with more and more strife in the country. And January 31st, Tahrir Square gets totally flooded. The military is called out to clear the square, and they can't because people are laying in front of the tires. And Mubarak steps down, and the internet ban is lifted. So last year, I was abroad in Kurdistan working with a university there to build out their wireless network. And while we were there, I don't know about you, but I do 99% of all of my research on Wikipedia. So while I was there, Wikipedia got blocked, and it was a huge detriment. And it was blocked in particular because there is a Wikipedia article that had a bunch of evidence of the Erdogan regime working with ISIS and training training people in Turkey to then go fight across the border against the Kurds. And Erdogan reached out to Wikipedia and said, hey, I need you to take that down. Wikipedia goes, I don't think you understand how Wikipedia works. And so Wikipedia got banned. So we reached out to the Interplanetary File System, which is a distributed system, was able to throw up a mirror. This is a shot from their blog. Took 5 days to undo what the Turkish government had done. So the reason IPFS works is a couple really good design decisions. One, like Git, we hash all the content so that your content gets compressed in a unique way, which means that it can be served from anywhere, and the content itself becomes its own like certificate authority, which leads us to trustless storage. Because the content is self-verified, I don't need TLS or any other TCP/IP security mechanism to make sure that it is what I'm expecting. It's peer-to-peer. It doesn't need TCP/IP. Two IPFS nodes on the same network without IP addresses will still find content from each other, and in that sense, it's fully distributed. It does not. It doesn't care about network partitions. I can start downloading a piece of content, get kicked offline, move to a different place in the world, plug into the internet or to an IPFS network, and start downloading the content exactly where I started. I don't know of another downloader that will do that except torrents. And yeah. But so the problems were like, it didn't work in a traditional browser. The documentation was in English, and we were trying to teach people about these high-level cryptographic things who were maybe new users of the internet. Most of the people only had smartphones. There's a lot of language barriers. People expect something like Wikipedia to just work, and in the developing world, it was treated with a lot more respect. I saw newspaper articles that quoted Wikipedia as a reliable source, which would not be accepted here. And so it comes with, it's a lot more official. I had a hard time explaining to people that I didn't work for Wikipedia, I worked with them, and it just didn't really work. Additionally, Wikipedia was unable to support this project because they were worried about their staff and volunteers in Turkey getting murdered. So that's always a consideration when you're dealing with big orgs. Make sure that the politics you want to play are actually something they can play with. So the Turkey blocks the same people who tweeted at the beginning. They did a randomized probe during the Turkish elections, and the internet. And this is a map of where the internet was working. If there were network outages, they would be red. There were gaps only because of the sampling. And so what we see from this is that Turkey took a cue and realized that it blows up in their face when they try to censor the internet. And so they didn't try anything during the election, and Erdogan still won handily. So Russia this summer tried to block Telegram, and it didn't work out so well. They ended up having to block like 2 million Google Cloud addresses. You know, that's, if you suddenly have like 2 million of your like 40 billion things go down, but it's like the most central 2 million, like everything kind of collapses. Total internet traffic was down that day, like 12%. And the reason they had to block so many IP addresses is because of domain fronting, where an application developer puts their application like Signal or Telegram onto a cloud service so that when I'm connecting to it as a user, it looks like I'm going to google.com or amazon.com instead of Signal's website. And regimes are reluctant to block that wholesale until Russia did this. They had never blocked it wholesale because of the collateral damage to things like banking, and even the country's own security operations probably are hosted in this cloud. And so in 1216, Egypt blocked all VoIP services, filing another round of protest against the new regime. And within a week, Open Wisdom Systems used domain fronting to get Signal back online in Egypt. And this is from May of this year, after the Russia shit happened. Moxie, who is the lead developer at Signal, got this from Amazon. So it's clear here that even though certain companies may have helped in the past, their goal here is profit, not getting people internet access. And because of that, the Telegram founder is offering millions of Bitcoin to anyone who can figure out how to solve these problems. Because right now, you cannot use Telegram in Russia without pretending like you're not in Russia. So we've all heard the social credit system in China. It's actually been a really long-term plan. It started with the Great Firewall in the 90s, and then there's Golden Shield, which is used to protect like national security secrets, and the Golden Cannon, which is a giant DDoS tool. And there's a new cybersecurity law that will roll out in 2020, in which every person has to use this app developed by Alibaba. That's essentially that episode of Black Mirror. Just going over that again. So China has 10 times the number of surveillance cameras as New York City. Just blew my mind. I had no idea. This was published by a newspaper in China about the long-term plans. It was published as not critical, but it's like, hey, look at all the great things this can do. And in a lot of ways, these are things we've instituted in the United States. We just call them capitalism. So, like, you know, this machine thing can figure out what school you go to, what job you get, whether you can leave the country. You know, it's really not anything different than we have here, except this is actually open, right? These are documents being planned and executed by like legislative branches. In the United States, we just have credit score and whatever Facebook sells to your advertisers. So, yeah. Here's the screenshot of the Alibaba app. It's in, I guess, alpha now, and you can get discounts at Alibaba, or you can get banned from Alibaba if you refuse to pay your creditors. It's pretty limited right now. And now the new move is to, instead of building these surveillance camera systems and getting people to watch these cameras and building in facial recognition technology and storing all that data, they're just going to recruit everyone who has the app. If you see something, say something, right? Yes. So yeah, and China has far and away the most users of the internet. So they're going to have nearly 1 billion people surveilling each other. you guys are familiar with this Cambridge Analytica leak, where 270,000 people were able to expose the data of 87 million of their friends in a variety of countries all around the world, mostly the United States. There we go. Everyone's favorite clip.
Thank you very much, Mr. Chairman. Mr. Zuckerberg, would you be comfortable sharing with us the name of the hotel you stayed in last night?
No.
Yeah. So we all know how we feel about it, right? So why is it that capitalism keeps doing this? Well, there's power. There's power in it. There's money. Steve Bannon worked at Cambridge Analytica, had connections to the original researcher, Kojin, and they all worked for the Trump campaign. And they allegedly used this data, although it hasn't been proven yet, to build psychographic profiles, according to Christopher Wiley, who worked for Cambridge Analytica. And they used those psychographic profiles to do the kind of targeted advertising to get people not to vote, but get to them largely to get people who they thought would vote for Hillary, to get them to not show up. And in general, here's some of the things Facebook knows about you. On the left, you've got, like things you've exposed yourself. And then on the right, here are things like, I have no idea how they get some of this. Like, how do they know what year my car, are they buying, I guess they're buying these records from DMVs? Why did DMVs get to sell these records? I don't understand. And so New York City is getting its own massive surveillance network. We call it Lincoln YC. There's 8,000 kiosk plan. There's 6 gigabits of fiber. There's been 42 terabytes of data transmitted on average across the network every week for the last 2 years since this has been rolled out. However, the average session time or session data is less than 100 kilobytes. So that means the average user is using it just enough to transmit some data to Google about, advertising or where they work or whatever. In addition, there's a Bluetooth monitoring radio for no reason. Like, it's unexplained. Anytime they're asked about it, they're like, oh, it's off. As if we believe them, right? There's 6 strands of fiber, which if we apportioned it like Optimum or Verizon does, would give access to the internet to 6 million simultaneous users. But as I said before, the average session time is less than 100 kilobytes. So this thing that could actually fulfill all of the Wi-Fi needs for the city of New York is used to, 90% of the power in that kiosk goes to that display. So it's just a billboard. It serves no purpose other than to watch you. Good news is there's some solutions. CJDNS. This is a distributed routing protocol that is absolutely amazing. It's decentralized, so it doesn't require the centralized naming system that DNS does. It uses hashed addresses that are generated randomly by your device, meaning that you don't need a central IP address authority to hand it out, and it uses IPv6. So you have that much larger address space, and because it randomly generates things, you could potentially have some collisions problems, but the likelihood of that is less likely than it's smaller than 1 over the number of proton atoms in the universe, the number of hydrogen protons in the universe. So it's just there's virtually no chance of collisions happening unless you have bad random number generation somewhere. And it provides both end-to-end encryption between me and a web server, but also between each hop in the network, so that I can't look at a packet header and trace back where it was going. And the only downside is I have to manually peer with people, which I don't see as a downside. It means that the people I can connect to on my network, I trust in real life. And the people they connect to, they trust in real life. And if you go on and build this out, we could connect all 6 billion people in the world in less than 6 hops. if you assume that every person knows 30 people. IPFS, this is what we use in Turkey. As I said before, it uses content hashed addresses. So it hashes the content and then that becomes its address on the network instead of relying on like a domain or an IP. It too is distributed. Anyone can run an IPFS node and the whole network will see it if you configure it that way. And then it federates, so like the data doesn't have to be stored in any one place. There are caching servers to keep the latency low, but if that caching server doesn't have it, it will happily grab it from somewhere else. And because there's no trust required, and because you're hashing the content, if you change the content by like introducing malware or something, the link changes, and so you can't introduce malware on an IPFS piece of content. And then mesh networks in general are really good. They're designed with the idea that things break and that networking shouldn't require a system administrator to work. And so they're designed to route around gaps in the network or failures. It doesn't care about topology, which means if you're connecting one person to 30 person, it always works the same, which means the barriers of entry are really, really low. We're working on some devices now that will be just totally plug and play. Updates will come remotely, and there's 2 radios so that even if one interface goes down, we'll have access to it. And the cool thing about mesh is when you have networks, wireless networks cooperating with each other instead of each one kind of carving out their own space in the spectrum, you can get more and more throughput in the same spectral resources. Through simulations done by the IEEE, that you can increase capacity of already in place networks by 1.4 to 7 times by including mesh routing protocols. And all of this is independent of TCP/IP. So we don't need the DNS. We don't need any of those problematic things that keep breaking, keep getting attacked by botnets. Everyone can just host it yourself. The main problem is in 2016, the FCC shut down essentially development on open source routers because they were worried that people were able to change settings about the radios and make them no longer FCC compliant. We figured out a way around that. We buy Atheros 9K chips and we put them on a custom PCB. This is called the Libre router. It was developed by Ultramundi in Argentina. And it's the first fully open source router stack. And we're shipping 2,500 of these around the world to 5 continents this summer. Early tests show that this can get full wireless in speeds of 100 megabits at 150 meters in downtown Toronto. That is, after years of working with mesh networks, this is single-handedly the best device I've ever used. Additionally, the radios are swappable. As you know, wireless technologies improve over time. Routing hasn't really changed since the 80s. And so, but radios change every 3 years. So we included the swappable ports so that you can buy the relatively expensive router board, and then in 3 to 5 years, when you need to upgrade for more capacity or bandwidth, you just swap the radio out for a few dollars in place. So this is a map of the city I made. I used a database from New York City Open Data that was a list of all of the city funded buildings, which means there's already wireless networks there managed by the Department of IT. So if we took one of those Libre routers, which at scale cost around $50 to $100, depending on like power options and that kind of stuff, we could have a citywide network in New York that covers 91% of the residents. And the total cost of this is, for the hardware and do it time, is around $20 million. The city's already spent $30 million on 3 failed wireless projects. One was to hook up 7,000 people at a project in the Bronx. One was to give 4G hotspots to people who live in neighborhoods that don't have 4G. And other ones have been small community grants that have disappeared as far as I can tell. So in conclusion, the only way to fix these like centralized failures of the internet is just start over and route around them. Any questions?
I have an answer for where your data comes from Facebook.
We do have a mic here. You can come up and use the mic.
Sure.
Great presentation.
That was a very good presentation. Thank you very much. The data that everybody knows about on Facebook comes from a company called Axiom Corporation. They have decided to sever their relationship with Facebook, but that's where the data came from.
That's wonderful information. Thank you. That's actually,
If you guys want to look up where your data is for sale, go to this URL, lists, L-I-S-T-S. Oh, slow down.
LISTS?
.nextmark.com. And by the way, their app on the phone stinks. Use a computer.
Thanks for the tip. Anyone else? Anyone else have questions? Oh, sorry. Lists.nextmark.com.
So,
Yeah.
so for the traditional internet stack, you listed a lot of problems with it. Has there been like a threat model for, you know, the distributed stuff that you're talking about, where there's like things that where there's like, you know, problems that we still have to deal with?
Given that we use some of this to combat a homicidal, genocidal regime and everyone involved in the process is still alive, I'd say it works okay, at least in the short term. Any other questions?
Where's a good centralized place to find more information on mesh networks?
So, yeah, Internet Society table. Check out the R Networks table, which is in the middle. That has people from Philadelphia, Massachusetts, Pittsburgh, Toronto, and we've got a couple people commuting in by Riot, which is a distributed and federated chat messenger. Y'all should use it. It's great. That's actually a big problem. We have a meetup tomorrow night with all the mesh groups here, and we are going to work on that problem because until 2 years ago, all of these groups were working totally independently, and we were using this hope as an occasion to start bringing it all together. And with the launch of the Libra router, we'll be able to get cheap hardware to anyone in the world who needs it, and we can all like develop on the same stack together, which will cut down our volunteer hours massively, I'm sure. Yeah.
Could you repeat where that meeting is?
So meet at the vendors spot. It's at, if you want to come grab some dinner with a bunch of mesh people from around the world, we're going to meet in the middle of the vendors area tomorrow night at 8 p.m. And it's at a table and it says R Networks. And there's like, you'll see a bunch of people hacking on routers and all these weird antennas, and probably no more t-shirts by tomorrow, but there are still t-shirts.
I actually have an interesting question.
Yeah.
You said you required to connect to your friends with the DNS. It's kind of
CJDNS, yeah.
CJDNS. That kind of sounds like the Ring of Trust in GPG, which has a notorious flaw as far as privacy goes, because now once you publish with the GPG, you have to publish your public key with the signatures, thus proving who all your friends are, which is terrible from a privacy standpoint because now you fingered all your contacts.
Sure. I mean, insofar as you've fingered a bunch of keys that aren't attached to any geophysical address, because we're not using IP addresses, the kind of surveillance doesn't really work. They can know I have 30 friends. There's nothing about a random string in my key file that would tell them who that person is.
Okay, so it's a key file, but it has to be communicated somehow. So there will be a network connection.
Yeah, it's a
Somehow.
PKI infrastructure, so.
Yeah, so in that case, now you have an IP address. This easily can get chained for people who do this kind of research.
Why is an IP address required there?
How else are you going to communicate this information?
CJDNS. It's not TCP/IP. It doesn't require that. That's the whole point. What it does, if you want to get really technical, is it randomly generates your IP address, and then to route you, it increments that to the closest known. Like if I'm at 1 and I'm trying to get it to 8, and I know 3 and 4, it'll move to 3 next because it's the next closest one to 8, and then it'll move to 4. It has nothing to do with geography. It has nothing to do with latency or speed. It has everything to do with fewest number of hops.
Okay.
Any other questions? Cool, thank you.